How this goes. I think we're recording.
Oh, so we're recording.
We're recording.
Oh, we are?
Okay. A right hand approximation, going to be very similar to the left hand approximation, except you start on the right side of your picture. So you're going to want to graph your function first. And now we need to fit 4 rectangles in here, but on the right side of our picture is where we would start. Okay, so based on that, I still need to divide this into 4 sub-intervals. So I know that I need to be looking at, this is a 1 still and this is a 2, but I need to be looking at 1/2, 2, 1.5, and 2. And I need to go to the right side of my picture to draw the first rectangle. So that's kind of tricky because the goal is you start on the far right of your picture, okay? And I'm supposed to go up to where this hits the curve. But how many do I have to go up before I hit the curve? I go up none, okay? So I'm going up none because that's where the curve meets it. And then I'm supposed to draw my rectangle across and then down. So my first rectangle ends up being a little baby nothing. It's a little baby line, okay? And what's the area of that baby line going to be? 0. It's just a line. There's no area. It's just 0. Okay. So my second rectangle is I'm staying to the right. So now I start here, and this is where this one ended. So this is where the next begins. I go up to where this hits the curve. I bring it toward the origin, and then I drop this down. My next rectangle, I pick up where I just left off. I go all the way up to where it hits the curve, go halfway across, bring it down. Oops. There we go. And then this last one is pick up where I left off, go all the way up to where it hits the curve, and come across. Now, this is, good job, this is a definite under approximation. The other one was an over approximation. This one definitely is an under. You've got all this area here, here, and here that's unaccounted for, so we know this is going to be less than the actual. Yes, sir?
So left hand always be over and right hand always be under?
That's what you're going to discover tomorrow, is if that's true. If that's true. Okay? Because that's scary to say always, okay? So what do we do? Well, the same bloody thing we did a second ago. We know our width all the way across the bottom is what? What's my width for all 4 of these rectangles?
1/2.
Good. So on all of these, they're a width of 1/2. We just have to find the y values now because we need the height for each of these, okay? So if I start with the one that I started drawing over here, I mean, y'all already told me that was going to be a 0, but you can see it right here if you write it out because the height is 0, okay? When we go to the next one, the x value that this one is when I hit the curve, that x value is 3/2. So I need to plug in 3/2 to our function. And I think, do y'all know the answer? Was it 7/4 or is that the 7/4 one?
I think it was 4, yeah.
I think it was 7/4. I think it was, I remember the 7. So that was 7/4, so that's going to go there. We need the height that goes with the one at 1. So where that hits the curve is at a 3. And the one that goes with 1/2 right here, and we got to see where that hits the curve. And if y'all remember from the last one, I think that one was it? 15. Cool. So now we map this thing out, and we'll get our approximation from that. So this doesn't matter. 1/2 times 7/4 would be 7/8 plus 3/2 plus multiply those 15/8, and then common denominator in the middle. I'm going to make you an 8, which makes you a 12, and then let's add that together. 21, no. 34, good. So 34/8. So the last approximation, it was 6 1/4, it was too big. This one is about 4 1/2, which is too small. So we know our answer is gonna be between this one, a 4 1/2, and the other one, which was 6 1/4. Yes, sir?
So to find the exact area, we can just average.
We'll find that out tomorrow.